Okay, we have to cover up the things whatever we have learned, and we have to do practice those things also. Okay, and the project thing is completely different. Okay, when we talk about the project, right? The project we are not using everything, right? We are using few things, but we are using mostly the application logic we are working on. Okay. The last time I was saying like one project I was working on, that requirement completely changed and I had to do rework. Okay. The requirement was earlier requirement was there, like when the files are coming, like 4 files are coming. Okay. And these files having the header and footer. Okay. So header lines are like I say ID, name, age. Okay. And this data is there. Okay, some data is there. Okay, and when I say next, one line gap is there, and after that one footer is there. There is a total number of record. Okay, and one amount column is there, total amount column. Okay, so these are the pipe delimited file. Okay, the total amount. Okay, so one column is the amount here. This one column. Okay, one column is the amount. So this amount column has some values. Okay. So this amount column has value. So here is a total number of records 2, and total amount is 60. Okay. So the thing is like this, total 4 files are there. This is the one example. Okay. Here is all pipe delimited. So this all pipe delimited. So this is like this kind of 4 files are there. Okay. I'm telling you the situation, right? How the requirement changed, and if you have not confirmed the requirement from the lead or anyone, right? So if because you have to take not only verbal communication like project, that is the reason we need a document, design document and functional document. What is the significance of the document? So that I will show you what is the reason, right? If we have not prepared the design document and functional document of our approach, because without that approach, then how can it go to the rework, or how it will be leading to the like your whatever you done, it was changed. Okay, so 4 files are coming. Okay, the 4 files are coming like this. Okay, and they said the last time they said like these 4 files are not there in the folder. One folder is there and they are landing these 4 files. Okay, they say this if the four files are not there, we will not process at all. Okay, even I say these 3 files are correct files and one file is the wrong file. Wrong in sense, suppose I say this is the 2 records, but here I am giving 1. So this is a trailer record. Trailer record is basically giving the detail about the header data, right? Body data, right? So if I'm saying this is the one type of error. So first type of validation was the number of files validation. Number of files validation. That was the first one. Number of files validation is like we have specified we will receive every day we will receive 4 files. We will receive 4 files. But today only 2 files came. Okay, 2 files came. So they said last time if 2 files are there, but we need 4 files, so we will not process. Okay, so we will send an email of validation. The validation will be 2 files are missing. So one email we will generate here. One failure email. Failure email will be saying 2 files are missing, and we will tell about these 2 files are missing. 2 files of particular name, right? Missing. Okay. So now they are saying like if the 2 files are there, do process it. You don't need to wait for the 4 file. If 2 are there, but prepare the message success and failure both. Now the message will be suppose 2 files are missing, and now the failure message will be different. Now it will not be called failure, it will be called a general message, right? Because it's a combination of success and failure. So I'm saying email message. Okay, this message this time it will say 2 files are missing and 2 files are processed. So missing files names will come, 2 files are missing with these names. Okay, 2 files are missing with these names. Okay, and 2 files are processed with these names. 2 files are processed with these names, and whatever output of these 2 files is separate 2 files we have to do and write into the SDFS. Write into SDFS success file. Success files means 2 files which are correct files. Okay. So now this requirement, now earlier we were stopping our process completely when the files are not coming equal, right? Whatever file we needed. Okay. But now the requirement changed. They said if 2 files are there, or 1 file is there, or 3 files is there, whatever number of files are there, you process it, and remaining file, right, which files are not there, you prepare the failure message for that. Second validation was there, like if number of files one, second validation is second validation is the record count and amount check. Record count and amount check. So that one is basically any particular, suppose these 2 files are missing, so that is gone. These 2 files, again, we need to verify. These 2 files, we need to verify. These 2 files, the remaining 2 files, these 2 files, verify for record count and amount check. Record count and amount check. If any one of the file is having this kind of error, so we will write one more failure message. But the one message is only one. We are keep appending it. So first we started message in the beginning, right? Message equal to blank. Okay. And here I got the message of the count one. I added the count message. Okay. So I added the message of failure message of count. So count message I added. After this, I added the same message. I added the record count and amount check message. So this is record count and plus amount check message. Okay. So this message I added, amount check message. Okay. And suppose here one more file left. Suppose I say here I got out of 2 files. I'm saying 2 files are there, but 2 files out of 2 files, one file is out of 2 files. One file is this record count error. Okay, record count and amount check error. So how many files is left for the next process? Only one. So here is, we started total 4, but we got 2 after this missing file. After that, we got 1. Now my third validation is I need to check whether this file is already exist or not in our database. Whether, because this file is already processed or not. So whether this file is already exist. So that is called duplicate check. Right? So I'm checking a duplicate check. This is a duplicate file check. Okay. So this duplicate file check, suppose I get this one file which is coming that is having duplicate check message. So I will add this message also. So the message is, so now all 4 files, so 2 files for the record count, 1 file for the record count check, 1 record count and amount check message. This is the one single message. And the third one message I added in the same message, duplicate file for 1 file. Okay. So total, these 4 files are, so now I don't have left any file for my success, right? Like finally I should process. But suppose in the same scenario, if I say I have only 1 file is missing, okay, out of 2 files, and here I say only 1 file is missing. So if I say, suppose for the last one, okay, that is my success file, okay, after all these validations passed, if only 1 file is left, okay, 1 file is left, so I will make it out separate, header part and footer part in 2 separate files. So that's logic. So now the requirement came, right? If any file comes, so this is the new one, right? Like when the files come, so whatever files are coming, we have to start processing of the validation. Now, one more further thing is there. Suppose we got 4 files, 2 are processed, okay, and 2 are failure messages, okay. So what their team will do, they will send this 2 failure messages, 2 failure file, they will send it again. 2 failure files, they will send again after 2 days, suppose, okay. Now the question comes, we have already checked of 4 files, right? Now we cannot, every time we are assuming 84 files are coming, then only we have to 4 files, the count is there. So suppose next time this 2 file comes for the failure, so this validation we have to skip, because count validation we don't need to do, okay. For the second time file is coming for the same date, we have to skip the count validation, because count validation is no point. Count validation is for the first time, correct? So how did I do this? I have created a one variable in Scala, skip count validation, a flag. Okay, it is very easy to you can very easily skip, right? So just you created a one flag with the false variable, and wherever, suppose I'm saying wherever I want to make it validation allow, I will make it this skip validation. Where I don't want to allow it, I will make it this skip validation true. So what I did second time in the record count check, right? The not record count, number of file check, number of files check validation. I made it in the same code. I put the one validation if my skip validation count equal false or true. Now if it is a false, initially it is a false only, I will make it true. Okay, so what I will be doing here, I don't want to do this count validation, but other validation again I will do, because they can do again mistake, right? They can do this mistake again, right? If number of records are 2, but they are sending in the trailer part record number 1, so that mistake can be again there, right? Okay, so we cannot rely on that, right? The second time when they are sending file, these files are 100% correct, we cannot rely. So these other second validation and third validation again will happen, and how many files will be left, right? Out of these 2 validation, then those will be success file, and again failure message will generate and they will send again if it is like a recurring process. Now question comes, how I will recognize if my 4 files are coming or it is a failure 2 files are coming, okay. So two scenarios are there, how we can identify whether it's coming my failure file of previous date or it is daily basis my current file. So there are the 2 scenarios. One is a current date files. So file naming convention, there is a date is there, right? Suppose I say file 1 2023 0908.txt. Like this kind of format is coming. Okay. So what I did for current date file, like which is my regular process. Current date file means which is my regular process, daily process, which is my regular process. Okay, daily process. For daily process, what I did, I created a one text file, backfill file. Backfill is, suppose some load, you want to run your job for a particular date. Okay. So what I did here in the backfile.txt file, in this file, I have to enter manually the date. So I got the email, okay, they are sending these 2 failure files for this particular date. So suppose they send the date like this date, they send the date. So the same date I enter in this file. I will make it this automation also. Right now, okay, I put it hard coded here, but I have a separate program. One Java class, some Scala class will be there. Every 10 minute interval, it will write all those dates. Suppose I got 3 different dates file. backdate file. So my code is not handling all 3 dates together and run a loop, right? My code is that also we can do, but second option I choose, I will enter in this backfill file one by one date in the 10-minute interval, every 10-minute interval, because why I'm taking every 10 minutes? Because once this file is processed, right? So the ingestion tool is there. One separate ingestion tool is there, which is reading every 10-minute files and writing the data to the Hive table. This data it is writing to the Hive table from the Hadoop location. So why we are running 10 minutes? Because that ingestion tool is running in the 10 minutes. If I process the file, suppose if I process the file, immediately I process for the second date. So my previous date file will be overwritten. Okay. So I have to keep it the same interval because my backfill file will be populated every 10 minutes with this date. Okay. This date I will not enter manually. I want to make it automate. What I will do, I will write a one Scala program, one main class Scala program. So write this backfill file, backfill.txt with date, specific date. So those dates I know. I say there are the 3 dates are there, 3 back dates. Okay, 3 back dates. Okay, I have a list of values of those dates. Okay, so I'm taking those dates. This program will take those dates and write one by one in backfill.txt every 10 minutes. So 10 minutes, why we kept it 10 minutes? Here we can make it even 5 minutes also or 2 minutes also, depending on our downstream system. So downstream system, which is reading those files, because these files are processed, right? Whatever failure is done, but whatever success file is there, after processing these files, once these files are processed, so the downstream system is processing. So that is taking 10 minutes. So that is the reason we are keeping it our program to write in the backfill.txt file every 10 minutes. Okay. So suppose 3 dates are there. So one by one date I'm taking. Okay. So first time when I get the first date in my backfill.txt, I got the date. Okay. So what I will do in my code, I will check every time I'm checking if backfill.txt is empty or not, right? If not empty, means this date is there. Actually, I'm reading, I'm just taking it some variable where my backfill date. Actually, these all methods I have written, I will give you. And then I will be reading here util, some class is there, new util dot get file read. Only one function I have created, how to read a file. Okay, so get file data. Okay, and that I am passing file name. So this function is my common function. Anywhere I can use it. Just I will be providing the file name. It will give me the file data. So file data is only this particular date only, nothing else. Okay, this particular date 2023-09-08. So I got this date here, backfill date. My variable name is backfill date. I'm checking not equal to blank. If it is not blank, so I will understand if it is not blank, what it understand, right? If we are processing not regular date. This is not regular date. This is for the backfill date. Okay, and backfill date means I will get all those specific date files I will take. There are so many files will be there. There may be current file also there, current date files, but I will be reading files. So list of files for this backfill date. Okay, I will take it those files, and the remaining process will remain same. Only thing is here we are deciding it based on the requirement, right? Whether it's a current date or whether it's a backfill date. Okay, else part I will keep it reading files for the current date. Current date I can get it, right? Now function is there. So there is the now function to get the current date, and then I will convert into the one format, and I will get the list of files for current date. Okay, current date file I will take it. So here what I'm doing here. So here either I'm checking the backfill is there or current date is there. So my regular, the scheduler is there now, which is running my this job, which can run for either of these two. Okay. So this either check it if it is a backfill, if it is not empty. And one more thing we have to do after the process file, this backfill file, we have to make it empty. If I don't make it empty, what will happen? So if you are not making it empty, it will second time when you run, when your program is running, again it will read it same. It will try to read same. Okay, even though file is not there, but it will be not running for your regular one. Okay, because our condition is there. When backfill date is present, it should always read the backfill. Okay. Otherwise, if it is not there any backfill date, okay. So first 3 dates will be coming one by one. So what it will do, my scheduler will be running 3 times for the backfill date. After that, it will start for the regular. Okay. If no date is there, my processor will be running, my scheduler will be running for the current date. Okay. And last I have to write back util class. I have a write function, write file data. So write file data, I have to pass what I want to write. So I want to make it some empty string for this particular backfill file. Backfill file. Backfill file dot backfill date. Backfill date dot txt. So this backfill date txt, I will be make it empty. Okay. So this is the logic. Another logic, right? When the files are not processed, and the second time the files are coming, and those are how to process it with our current process. So we don't need to break our current process. So current process, just I put it this code that is handling both the scenarios. Okay, for the current date process as well as the backfill date. Okay, and backfill date also I made it automated here. User has to run this main program whenever he's ready. So he just enter the 3 dates. Those 3 dates will be entered in this backfill.txt file every 10 minutes. Okay. So every 10 minutes, the scheduler will run and then it will fill all those, like process the file. Okay. But the validation process will be same. That is no change. Either it's a backfill is nothing but those files which are failed last time. And now we are assuming it this time they are correct. Okay. So and the new logic came, right? They don't want all 4 files to process together only. So now the new logic is saying, they are saying even 2 files are there. Okay. So this new logic now it is helping for the backfill process, right? Otherwise backfill process we can't implement it. If we are keeping it the scenario, we will only process the 4 file, otherwise we will not process. Okay, because our process will stop in the beginning itself. So what the new change that is helping to the scenario where the files are not processed, and the next time those failure file or the files which are missing, anything like all those scenarios, it will be handled. Okay, so whenever we are starting, right, so we have to prepare the design and functional document. Suppose I got some story, and my task is I need to design, implement, testing, ETL pipeline from file system source. These are the 5 delimited file. Okay, and process it into 2 separate file in the header and footer, 2 separate file, header data and the footer data, and keep it on SDFS location. So some location they have told Loomis. So Loomis is their business term. Loomis like the type of files. Okay, Loomis type. So Loomis, they are saying this is a 5 delimited. Another second requirement they gave, they are second fixed width delimited file. Fixed width delimited file, there is no delimited character. Fixed width delimited file is, suppose I say I have a ID, after the some space, name is there, then age is there, and then amount is there. So I say the fixed length, I say 2 character is the ID. Okay, 10 character I'm giving for the name like this, and age I'm giving only 2, and amount I'm giving 7, 8 character. So here I need a schema here. I need to know here what is my starting position and ending position for the first column. What is my starting and ending? So this detail is there. So this detail is there where starting ending positions are there. I have to create a schema for that so that I can parse the file. I can parse this file, and now I have already logic for pipe delimited. So what I thought, if this file, if I convert into the pipe delimited, so my just I need to, if I convert this fixed width to, and here is also one footer column. Okay, like amount, and amount. Okay, here is also no fixed delimited character. Okay, so I say I just convert this fixed delimited to pipe delimited. Okay, if I make it this pipe delimited, same like this one, this kind of format, pipe delimited, this one. Okay, in the pipe one. So if I make it this, so whatever work I have done for this pipe delimited, everything I can do it, right? Whatever validation I've done. So I don't need to do separate validation. Suppose if I do directly process this one and write separate validation. So validation I can use it same. Validations are same, only the format came different. Here the format is a pipe delimited, here the format is fixed delimited. So what I did, I initially wrote some logic for handling this fixed delimited, right? That logic is different. I written some logic how to parse this file and convert to the pipe delimited. And I converted this file to pipe delimited and given as a same like this file. So my entire process, which I'm using this all process, it will be utilized. So only logic, what I need to write logic, I need to write a logic and making it fixed width to file delimited. So I have created a data frame out of this one. So that is easy, right? Getting a data frame out of fixed width, delimited. I got it, my data frame. After getting my data frame, I convert to the RDD, data frame to RDD. Okay. And then I iterate my RDD, and I have appended all columns pipe delimited. All columns pipe delimited. Very simple logic it is, right? So my data frame, I got the data frame out of this. I convert it to RDD and iterate my RDD, and all columns, even it is a header or footer, I convert it to pipe. So now my file has become, now my data, not file. Actually, I didn't save the pipe delimited. My data has become now pipe delimited. Pipe delimited. Okay. So my data has become pipe delimited. It came on the same stage. Here I'm reading the file. I'm reading the file and getting the pipe delimited data in the RDD, right? Same data I got it here. Same data I got it here as a pipe delimited RDD. I got it pipe delimited RDD. Pipe delimited RDD I got. So same thing I'm doing directly from the file here. Same thing I'm getting directly from the here. When I'm reading this file, I'm getting a pipe delimited RDD. Same thing I got it here. After that, the entire process will become same. So whatever functions I created for these validations, everything, I can put it in the util file. I mean, right now, I gave the name of this file. This one is pipe delimited file splitter. Pipe delimited file splitter. This is the name of this class. Okay. This is my object, the main class. Okay. I'm telling you how to separate the logic. First, I created with this entire logic. My object name is pipe delimited. Second object I created for my fixed width name, fixed width parser. Okay. Or splitter, anything you can say. I give the name fixed width parser. Okay. how many logics, like one logic is there fixed with to pipe delimited. That is separate logic. But the another logic, which is this logic, this logic, this logic, till this logic, this is a one logic. But after this, whatever this validation logic, the same logic is here also. Okay. This logic is also, because the processing of the file will be the same, because the format is only different, but the processing of the file, validation of the mass files, all those, everything is same. So what I need to do here, this code is completely repeated. This code entirely repeated, because this all are the functions. I have created like a function. I didn't write a code in the main program, main function, because main function, I'm just keeping it the code which is calling these functions. Okay. I have kept it all this as a like a function. So I will move it all these functions to my util class. One class I will create. One util is, that is general utility function. General utility function, I can say like a date conversion function. Okay, date conversion, file or reading and writing function, file reading and file writing function. Okay, those functions are there. But now another util class I will create. I will say splitter, file splitter util. Okay, file splitter util means whatever my fixed width file or pipe delimited file, this validation masses logics are there. I kept it into all my functions of validation messages. Okay, and processing and validation message and success file processing logic, which is common for all file formats data. Tomorrow, if I say some new requirement come, file format data. Suppose tomorrow new requirement come, I got the JSON file. So JSON file, I got it, same file data, the same ID name age. I say this data coming in the now JSON file. So now JSON file format will be like this. Okay, suppose some ID, then comma, then like I have a JSON format. Okay, so if my data is coming like in this format now, some JSON format. Okay, now this JSON format data is coming. So same thing, what I will do, this process I will follow. What process I will follow? Same fixed width file format, I created a data frame out of this fixed width file. Then df to RDD, iterate RDD, all column pipe delimiter. I will do this. Same thing I will do it here for the JSON. So out of JSON file. So out of JSON file, I will get the data frame. But this JSON could have nested JSON also. Like suppose these files are the maybe different files also. So some nested JSON, so we have to use explode function. So explode function to bring out nested column in the JSON to bring out nested column. Okay, so nested column we can bring out outside, outside. From nested column. So once a JSON file, I will create a df to RDD, iterate RDD and file. Again, this all logic your will be utilized. So your this particular main class, this JSON splitter class, this is a JSON file splitter class. So you will see in this particular main class, okay, these three main class, right? These three splitter class, right? This will have only just logic, how you are calling this validation logic. That's it. And validation logic is at and one place. Whatever validation logic you are doing, count, file count, everything, right? Okay. So this is the one type of file. Okay, it's file system file, like CSV file, JSON file, XML file, or any file could be. So file system scenarios could be, this is, I mean, so far they have fixed width, pipe delimited, or in the future it can come JSON, CSV, XML, or maybe Parquet, Avro, any type of. Okay. And if I say just I need to add one class, okay, I will add, and how much fast this logic will be? Only thing is you have to concentrate how to read file and convert to pipe delimited data. That's it. This one function you have to write. And this function you are just writing for the all different file formats. Your all entire transformation. This is called transformation logic. So that is the reason we say like reading and writing logic could be different, depend on the source or target. Okay. I mean, right now the target is everything is a file system only. In all the scenarios, our target is we are writing data as a file, writing data as separate files. Okay. These separate files we are writing as a pipe delimited. Okay. Pipe delimited, because why we have to do pipe delimited data? Because the downstream system which is reading these files, that is reading pipe delimited, because they have pipe delimited only. So every type of files we are converting into the finally into the pipe delimited only. So that is the reason we are reading a different file format data, convert RDD and pipe delimited data RDD and writing it to the target as it is. Okay. But validation message logic transformation is there before writing to this. Okay. So either we have to reject the file or we have to just write the data. But there is no change in the data. Data will remain as it is. Only thing is the validations are related to file level validations. Either file is missing, file trailer record count is missing, or file is a duplicate. So those kind of validation. But suppose if I say file data validations can be also we have to do. So this pipe delimited file we are going to write. Before writing file, suppose we want to add some new column. They say we want to add one more new column while writing the file. We are writing the file as it is this one, like pipe delimited. So suppose they say when you are writing two different files, one file for this and one file for the footer data. So you add one column file name, because this particular file name data is coming. So you add file name and the create date also. Okay. Because when the downstream system will read, so it will come to know this particular file data. Okay. Because when it is reading the file. Okay. So it will insert the data into Hive table, the downstream system. So we have to add two additional columns. So here simply I will do, when I get the data frame out of this data, okay, the original data, the source data. So before converting RDD, I will add two column here, df.with column. So first column, I will add the file name column, and file name column, already I know the file, right? The entire file I'm reading, right? So I know the file name. So I will write, so lit is there to, like as a constant, I can write the file name. So this is the file name. With column, I want to write date, right? So I say create date. So create date is a date when we are writing the file to the Hadoop file system. So that date I want to. So I'm just specifying the current date. So current date, whatever current date will be there, that time it will be right. And then I will convert to the pipe delimited RDD. So the downstream system will read this file and write into the Hive table, and further process they will do. Okay. Okay. So this is the, say, ingestion can be from anything, right? Ingestion can be from any source. So we are talking about ingestion can be anything, like it could be a file system data. It could be a SQL database data. It could be a NoSQL data. Okay. It could be a real-time streaming data, right? Like data is coming through REST API or some Kafka, okay, REST API or Kafka or anywhere, right? So ingestion can be happen from anyone. So when I'm talking about, like, I have to do the similar type of ingestion, like I have to read the, instead of the file, I want to read the data from the SQL database. So same data is coming from the table. So I have to write a logic only for reading the data from the table, and then the same process I have to do. Okay. So here mostly work is the ingestion side, right? Because target is for all the type of data which is we are reading, that is going as a delimited, pipe delimited only. Okay. So this is a one ETL pipeline example. So here when we are starting the work on the story, right? When I'm saying, so suppose I given my 5 story point, 5 story point, I'm saying, okay, this is a 1 week story, one story point for 1 day, 1 story point for 1 day. Okay. So I say ki 1 day I can reserve for documentation. Documentation, you start first functional document, because functionality is important to understand functional document. The functional document, you are defining the flow of your pipeline, business flow of pipeline. So can you tell me, right, in this one, what is the functional part? Like if I'm saying in this entire pipeline, like suppose I take example of 5 delimited file I'm getting, and I'm just doing this processing of logic. Okay. So what is a functional flow, business flow in this? Anyone can tell what is a business flow? What are the type of logics are the business flow logic here? What business means, like domain, right? Business domain, we call it, right? Okay, if it is a healthcare project, so healthcare related files will be there. Definitely it will not be processing the financial, right? So financial domain will have financial files, so that is understood if the data will be related to that particular domain. But now in our this use case, if I say what is the business, so business is, right, the validation process is the business, right? This entire validation, because they say what is the sequence of the validations, right? The sequence is like count validation, file count validation, and then record count and amount validation, and then finally the duplicate record file validations, and all three pass, then our file will be separated. Okay, so this is the entire business flow, right? So one document you have to prepare, there you have to show your understanding of the business flow, right? How the data is coming, from where the data is coming, what the process you are going to follow. So this kind of business, now you have to write it in the document, means like take a one file as an example and tell about how you will be going to process, right? Okay, like first validation, number of validation, first validation is number of files validation. Then you write it, the theoretical part, right, about the validation, how will you perform this validation. Okay, so this is a functional document, and this document you have to get it approved from the BA. This guy, if they did everything, if he took approval, so he could buy more time, right, for this rework. But he has not approved, and he has not cleared the requirement before getting from the BA, and confirmation he didn't take even the mail communication or like through anywhere. But that is the reason the problem came, and now they have asked to develop this within a 1 day, right? Just they have given only 1 day. So Monday the guy has to give the presentation for the new requirement. Now the thing is, like, this is entire, if I say that other earlier requirement for the all file to process together, and now the requirement is completely changed. So everywhere the change will happen. It is not at the one place change. It is everywhere, right? Because earlier the logic you written in a different context, and now you are changing the logic in a different context. Okay. So if this is done before, so that is like you are safe, right? You will be getting enough time if the requirement change from their side. Okay, because they will give you enough time, because that was not your mistake, right? Because you have got the requirement, you get it approved, and then you have started work on that the requirement. Okay, next document you have to take a design document. That is also, this is more important also, because in this design technical document, where you are designing and implementing your technical approach, design and implement technical approach. Okay, so what is a technical approach here? So here, if I say my technical approach is like, okay, I'm using a Spark Scala or PySpark, that's the one thing. Second thing is, when I'm just reading a file, okay, and which type of logic I'm using. Okay, so technical logic you have to define in this. So you have to tell you are reading files. Okay, you are writing a separate classes, right? Reading logic, reading logic for separate classes. Okay, Util classes you have written, util classes you have written, util classes you have written some, uh, but you have to say in the flow. No need to say like separate classes name. Just say about the flow in the technical manner. So when you are starting the reading, so what this entire process you implemented, how technically you are going to implement it. So if I say I'm reading a first this pipe delimited file here, okay. So pipe delimited file I'm reading here, okay. I'm reading the data, then I'm applying this validation, then this validation, because entire code you cannot show in the document, right? And it is not possible also, or it is not a good idea. So you have to say high level technical approach, because when the code will be reviewed, so it will be reviewed as per the technical document design approach. Okay. So you can show this and then you get it approved from the, this will be approved from the architect. Okay. Who is the technical architect, that technical architect. Okay. And this will be approved from the business analyst, BA. So business analyst guy will be approved this one, so that you will be on the same page for the functionality. And technical architect, because this part will be not that much rework problem. The problem in this rework, like functional logic, because if functional logic is changed, so entire job you have to test again from the scratch. Okay, because your testing will be completely rework. Okay, so I'm saying if one point is something is changed, so that will affect in the entire flow. If I say the changes happen here in the count logic, so after that every logics you have to test it and verify. Okay. Okay, so this is the project related things, right? I discuss about, right, how the project generally the complications comes, and like how to overcome all these things, and how to be aware, be prepared, right, of these kind of scenarios. But this kind of things, like now, if you have already this kind of project experience, so it will be feel easy, right? Because it could be difficult for those who have not implemented this kind of transformation logic. Okay, like how to read property files, how to convert into the map, and then write a logic like this technical logic. Like sometimes you are thinking, okay, I have to skip validation. So same function you have written, but you don't want to perform one type of validation. So just use some flag variable. Okay. And one more thing I'll tell you. Actually, every failure message, there is a one note is there. Technical guy will check it and revert back. Okay. Earlier, what happening, because separate failure message there, like one failure message come count one. So this line was there, every message. Okay, like failure message. If count is passed, the second failure was the check count or amount check. Okay, so there is also this note is there. Ab now question comes, ab now our logic is changed. So like this also repeated, right, every time. So I don't want to repeat for every failure message, right? Suppose 4 failure. Now the whatever the message, like email message body we are writing, in this email message body, the first failure message will be coming for the first file. Suppose failure message for first file. Okay. And there is a note is coming. Okay. And again, second failure message in the same message, I'm saying it is coming for failure message for the second file for second validation. Okay. This is first validation. Okay. This is in the earlier approach, it was repeating, it was there, right? Like this every message. What I did, I have removed from everywhere. I kept it one flag. Flag validation support false. Okay. And wherever I know, right, if any one of the failure comes, it means finally I need a message, right? Even it is a 2 failure or 1 failure, I need a one note, right? for either if the 2-time failure is there or 1-time failure, it doesn't matter, or 3-time failure is there. Okay, message will be the same, correct? So what I did here, validation failure support, I made it false in the beginning. And if even I'm getting a first one in my logic, okay, so this variable I made it, okay, I started in the beginning, same thing like skip logic one. So I did here, yeah, this one, I make it here. And now when suppose I come to here in the first one, okay, so I made it validation support true. So validation support true means up this support either one comes in the any one of them, any one of the failure messages, it comes, I make it true. But finally, I'm checking it at the last when I'm finally preparing my email message, right? I will be checking if condition, if any validation support is true, whether it came from the 1 or 2 or 3, it doesn't matter because all are the true, right? So I have checked it and only one time I'm just printing it. So I'm checking if validation support is equal true, it means I have to give this message. So this is the just right now repeating things I have removed, right? Okay, correct. So I don't need to write again like every failure message. Okay, the technical guy will revert back technical. So this is only one time is enough, right? And finally, after this, the success file message, success message file. Okay. Okay, so this kind of things, think about the logic, right? Okay, what type of scenarios is there and what type of logic you want to write. Okay, so that will be giving you how to, because otherwise if you want to make it different way, you can do it. But I believe that this is the easy way, right? It's something you don't want to repeat again and you want to write it only once at the end, so you can use the flag thing. So flag thing will help you. Okay, so that will be helping you to write. So you will see the code, you will see as many as logics you can add depending on the check, depending on the conditions, depending on the scenarios. You can add this kind of small logic, and that will make it your code complex, right? If you have not properly documented code, if you have not given the documentation on the in the code every steps, right? So anyone will be not able to understand. Okay, okay, is it clear this one? Okay, I want to show you that code. Okay, so next is okay, so like interview preparation questions, right? So interview preparation questions, right? So if I'm saying the Hadoop side, so Hadoop side, mostly the topic, the first is the Linux fundamental command. So shell scripting is important. Linux shell scripting and Linux command. So these two things. So here you need to brush up all the basic fundamental command. Okay, basic fundamental command, like they are the different category of the command. You go through the category wise, like memory management command is there, and process commands are there. Some like file system commands are there, right? So, and these are the category of types of command are there. You can see any documentation there. You can understand like some file commands are there, copy command and remove or this command. Some command are the filter commands are there. Filter commands are like I say, grep command is there and find command, like something you want to filter, right? Okay. So those kind of command, and then you can do shell scripting practice. Okay. Shell scripting, just simply start from the basic shell script, right? Suppose you are writing some conditional logic you want to write, you write a file, you read a file. So there is a simple Unix shell scripting. Okay. And you can use awk, 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 and you can use SED. SED is for the find and replace, or something you find and something you want to change in the same file. So you don't want to create a new file in the same file you want to modify. So you can use the find and replace things in the using the SED. And next thing is comes in the big data fundamentals. So Hadoop concept comes. So SDFS. To go with the SDFS developer commands, practice all the developer command, 30-40 commands are there. all developer commands, you practice from the scratch and check like how can you write a command. Suppose I ask you two files I have in my local file system and I want to make it one single file. So somebody is not telling you the command, right? You have to think about, okay, there is append to file command is there. Append to file. That is taking local file 1, local file 2, or more than 1 or 2 you can give. And then final file is a Hadoop file. So Hadoop file is your target file where you want to write the merging of these two files. Suppose I want to have a 2 file in my Hadoop file system and I want to get one single file in my local file system. So you will use get merge command. So you should be very aware of each and every single command in Hadoop, right? Because these are very basic fundamentals. If somebody is not aware of very basic command, so that is like main point for the rejection, right? Because you are how you are doing day-to-day activities. Because in the day-to-day activities, right, when we are working on the edge node, most of the times we are checking the file status and copying files, those things we have. When you are working for the Hive, that time also you should know very well the Hadoop command. Otherwise, you can't check whether the file table is created in the Hadoop file system or not, whether the table is populated or not. So some of the times you are checking the tabular data in the Hive shell. You can check tabular data. You can check in the Hive tabular data. You can check. But suppose in the backend data you want to check, right? You want to verify the data whether it's there or not. Okay, you cannot understand, right? Okay, whether the file is when this file when this table is the last updated. So you can't come to know from the table. You can't come to know. You have to go to the SDFS and check the table file status, right? What is the status of file when this file is updated last time? Okay, so any Hadoop command is important. Then Hive is there. Okay, so if I say MapReduce, so MapReduce is basic fundamentals of the MapReduce concept is important. Basic MapReduce concept, but it is not 100% required. But I'm saying MapReduce concept, especially those concepts are which we have, because the MapReduce is the key pillar of like a base is the MapReduce only. If you use Hive, Scoop, anything that is converted into the MapReduce only. So MapReduce architecture, MapReduce concept, right? MapReduce join, right? Map side join and reduce side join. Okay, reduce side join and partitioner, right? There is a partitioner and combiner. Okay, so these logics are enough, right? This concept, and if you can understand and write little bit code, okay, just code snip, okay, or if you can make someone understand what is concept of partitioner, combiner, map side join, reduce side join, that is good enough. Okay, because this concept is not to write in the real time, you will not get any code. Okay, you will not be able to write because nobody is asking nowadays to write a MapReduce job. Even Pig is nobody is asking. So mostly you will be working in the Hadoop side. The component is Hadoop commands, Hive, Scoop, HBase. Scoop also you will depend on the requirement, because mostly ingestion we are doing with the Spark, right? We are doing it because Scoop is just doing ingestion only. But Spark is not only ingestion, it is doing transformations and complete ETL. But Scoop is providing only ingestion of the data. It cannot do any manipulation, ingestion only, right? So when you want to read data from any RDMS database to Hive table or SDFS, right? Or HBase table, right? So you can write the data using Scoop. But there is an alternate Spark is there. Okay, but Scoop, if you know, that is good, because Scoop concept sometimes they are using only ingestion only. They don't want to do any transformation things. Just simply, I want to read data RDMS and write the file as it is. Okay, suppose just the RDMS data I want to write as JSON file. RDMS data I want to read and write a CSV file. Okay, or Parquet file. Anything you can. So we can define through Scoop. Okay, we can do that. Or HBase is also needed, NoSQL database. So NoSQL database category, that is a part of the Hadoop ecosystem component. So Hadoop ecosystem component. So it's a column family database. So you should have the architecture of HBase, okay, and HBase commands also there required. So those are the CRUD command, okay, like the CRUD command is those are the scan command, get command, okay, put command, get command, put command, okay, drop command. So all the DDL, DML, all types of commands. So these are the DDL, DML, and these are the commands also. So HBase we should know, school we should know, Hive, MapReduce, HDFS, and little bit knowledge if you have Flume, that is fine. Otherwise, Flume nobody's asking nowadays. So Flume ingestion is basically we have source, channel, and sink. Okay, the three components are there. So we should know if the source is the, suppose I'm getting the data from the external file, Hadoop file system, some local file system to Hadoop file system. So I use spool dir. So spool dir is a one way. Another one is a source type is a execution type, right? Suppose I want to run any Hadoop command like tail command, cat command, I can do. Or something like I want to read data, streaming data, right? Suppose I want to read data, streaming data from Kafka or Kafka, or I can say Twitter. Okay, so there is a different source are there. So Kafka, there is a Kafka source, and for Twitter source is there. Okay, so your source will automatically change if what type of data is coming. Okay, so if your data is a file type data, so your source will be spool dir type. If your data is like a command, right? You are running some command for some location of the file, right? Cat command tail. So that is called execute command, execute type. Otherwise, your source is a source. There are around plenty of sources are there. Avro source is there. There are different sources are there. Elasticsearch source is there. Mongo source is there. So different sources are there. So you can define these things, but basic architecture you should know, and you should know spool dir and execute type, or little bit right how to write a conf file. So in Flume we are writing conf file. This conf file is defining source, channel, sink property. Okay, so these three type of property we are defining. The source is from the data is coming. Channel is a medium. So generally the channel is either file channel or memory channel. Okay, and the sink, I say what is my target. So most of the cases when I'm talking about the Flume, SDFS sink I will use. There the other sink are there, Kafka sink also there, but when I'm saying I want to get the data from source to Hadoop file system, so definitely the sink will be SDFS sink. Okay, or some sink is like a logger sink also there. Logger is basically like here when I'm spool dir, this one I'm doing tail and cat command. So I will use logger sync. Logger sync is means my console login. I want to see the output. Console login, console see output. On the console itself, I can see output. It will not generate any file. It will show the output on the console. Okay. So if I want to write as a file, I will use SDFS sync. If I don't want to write a file, I want to just display output as on console. Okay, so I can use the logger sync. So logger sync we can use. So depending on the use case. Okay. So in the Hadoop, this is all 6 components. Once you prepared with all these 6 components, then your entire Hadoop is done, and then you come to Spark. So Spark type. So Spark is only 3 module is there. Core, Spark SQL, Spark Streaming. Okay. So when I say core, so first of all, in the core, I should know very well about the transformation and actions. So I should know every use case of the transformation and actions. Okay. I should know map, flat map, filter, join, group by key, reduce by key, and action, right? There are the different actions, right? Collect is there, for each there, count is there, take is there, take order is there. So different action use cases I should know. And transformations, like I should know union, group, reduce by key, group by key, reduce by key, group by key, map, flat map, filter. So these are the transformation, right? And every transformations we should know if my through RDD and through data frame, 2 things are there. So these same transformations can be applicable for the RDD and data frame. Okay. So how I will be doing these transformation using RDD and data frame. So first of all, I should know the concept of RDD and data frame. So RDD is a basic fundamental unit, right? And basic fundamental like measurement in the Spark is RDD. So any unstructured data which I'm reading, okay, unstructured data is nothing but text file data. There is no schema. Text file data with no schema. That is my unstructured data. Okay, so there is no fixed dimension. If I say this entire data is my text file data and there is any fixed column is there, is no, right? So this kind of data, when I'm reading it, it will be read as a RDD and it will be iterate through row by row. So when the dimensions are not there, where there is no fixed column is not there, so I have to read the data row by row, like this, like this, like this, like this, like this, I will go. Okay. But when I say my data is columnar data, right? Like a pipe delimited data or data, I can say CSV data, JSON data, XML data, Parquet data, ORC data, or SQL file data, no SQL data. All I will be reading as a data frame because I will get a fixed column. Even SQL table you will read, you will have the fixed column, right? Your data will, some data could be blank in the some column, but ultimately the number of columns will come same for the entire table data. Same like a file also, JSON also, XML also. So when you read this data, it will come as a data frame. So you understand the only text file data when you are reading that is unstructured, and remaining data, any data, right, from any file system or SQL, NoSQL, all are the structured data. And this type of data, file system, NoSQL, SQL, okay, or then you can say if the data is coming a real streaming data, again there are the two categories there. So one type of category is the RDD data can become, or one is the data frame data. So there is a two type of division is there. Like one is D stream. So D stream is a sequence of RDD, sequence of RDD. So which way you are reading the data? The data which is on the Kafka, that is the same. But what is your approach? Are you reading the data as a D stream approach or structured streaming approach? So structured streaming approach you are reading, that is called sequence of data frame. Same data is coming in a two different way. Why? Because either you are applying a D stream or structured streaming. So sequence of RDD, when you are reading a D stream way, that is more complicated way because it is already RDD and RDD of RDD is there. So D stream is a RDD of RDD. Different RDDs are there. So one RDD, you know, right, how much complicated to process, right? It is really complicated, right, to process row by row. And again, it is a RDD of RDD means it will become more complex. And if I say it is a sequence of data frame, so it is more easy, right? Like data frame, like I know the columns and I know particular column I can process, right? Okay, I can do transformation easily rather than applying the transformation on the RDD. Okay, so there is a one more way is there. If this RDD you convert internally to data frame and then process and convert back RDD, convert to RDD. That is the one other approach is there. Okay, or directly you read a structured streaming. This depend, right, which method you will be using. If you are using here Kafka util class dot create direct string. If you are using this function, it will be giving you these. If you are using Spark dot read string, and here you are telling about format. So here you have to say the format, okay, Kafka. So function is the same. If you are reading a data from the file as a streaming data, just say file here. If you want to read a data from format, it will be a file. If you say format, okay, you say format, you can say, okay, I'm reading from the socket. So I say socket. So I'm just telling about, only thing is here, I'm defining here the format. Okay, I'm defining here the format, and that format I'm reading the data, and this is coming as a structured streaming data. So you have to go through both the approach, and for all the one, the same like a file stream data, Kafka data, socket, whatever I can do with the structured streaming, Same I can do with the, same I can do with the RDD also here. So I can do for the file, okay, Kafka, socket, okay, I can do, or console. Console is there, right? Basically, we can read and write to console, okay? So there is a format console is there also. So here is easy is like you don't need to remember all separate functions. Here is a one function is a create direct stream. When you are reading a file, you will be having create file as a stream. When you are reading as a socket, you will be having a create socket as a stream. So your function name is different functions are there here. Create file as a stream. Okay. When you are reading from the socket, create socket as a string. Okay. So these functions are there, right? So you have to remember, right, all the functions, right? Which functions you are going to read for which type of source of data. Okay. So when I'm talking about the transformations, right? So I can use this transformation. SQL is completely deal with the batch data. So batch data is SQL. See, core is common for SQL and streaming. And SQL is only for batch and streaming is only for streaming. Okay. So batch means here it could be a file system or NoSQL. This kind of data is basically SQL, or any other source could be there, which is like some tool you are saying, right? Okay, Tableau integration, Mongo, Cassandra. So this will come in one category. Okay, BI tool, I can say. So there could be any category which is reading as a data frame that is called batch. And when you are getting a data as a stream, that is called the real-time streaming data. Okay. So you need to prepare on the performance tuning also. The performance tuning is Spark performance tuning, Spark job performance tuning. Okay. Like how can we improve the performance of the job, Spark job performance tuning. Okay. And many more concept related to as the interview questions mostly comes like definition questions come, some scenario questions come. They ask about how to how to define number of cores, executor, driver memory, right? Core, executor, driver memory, executor, driver memory. How much driver memory you need, executor memory you need, right? For some certain data, for some certain amount of data. Like they can ask 100 GB data is there. So how much this configuration is needed? What the configuration? Certain amount of data. Okay, so this kind of question is a scenario questions, and some are the like direct straightforward questions. They can ask some coding questions. Like they will give you the data, CSV data, and they will ask you, can you do on the group by windowing function? Okay, you can do the drop the duplicate data, remove duplicate, right? Okay. So this kind of questions comes where like they ask technical scenarios. Like it's a similar type of if I say like I have a file is there and I want to do this like a project, how will you write the logic? But they will ask you to write pseudocode, or actual code, pseudocode or actual code to demonstrate your technical ability. Technical ability is like basically you are how you know write code, right? Suppose I say how to read CSV file. So you should know, right? Val RDD equal to spark dot read dot text file. Okay, I want to read RDD. Spark context, because I have to use parallelize function. Parallelize, and then I will do the file. So I can read the RDD. How to create a data frame out of the CSV. I want to read a file with the header in the CSV. So there is a option header equal to true is there. I want to enforce the schema, right? I want to read the schema of the file. Like what are the columns are there in the CSV file? I want to read those columns. So there is a info schema true. Info schema property is there. I have to make it true while we are defining the option. Okay. So those things we should know, right? Okay, when you will see the live coding examples, some coding examples you will see this kind of things are implemented. Okay. So when you are reading this kind of data, right? So you are defining those kind of. Okay, when we come to the AWS like cloud, okay, so cloud thing, okay, so first of all, AWS basic common services we should know. Okay, so AWS common services we should know like EC2, S3, RDS, DynamoDB. Okay, in one interview they asked me what are the different errors in AWS EMR. Of AWS EMR, there could be possible errors are there, like it could be a file input output error. Okay, it could be a cluster errors, right? Cluster errors could be there. Cluster error means like your cluster has not enough resources are there. Sometimes not enough resources, memory, right? Resources, memory, CPU uses, right? So there are could be any kind of problems could be come, right? Because EMR has the two things. One is a cluster, and in the cluster, your job. So application related error could be there, or infrastructure related error could be there. Okay. So those are the different errors. Like he was asking about how will you do the follow the best practices in the AWS EMR. Okay. So AWS like, okay, and some cloud services are there, AWS cloud services. So there are the cloud services, AWS cloud big data services. So big data services we will be using, okay, Lambda, Glue, okay, EMR, Kinesis, okay, okay, and DynamoDB, RDS. Okay, these are the common services you can use it the cloud big data. So these services we should know the use cases, right? Okay, if I say Lambda has a different triggers are there, around 10 to 15 triggers are. Okay. So API gateway is a one trigger, file S3 file is a one trigger, right? S3 is a one trigger whenever the file is arriving in S3, so it will trigger the Lambda. Or when EC2, like I say, some Kinesis stream, right? So Kinesis stream will trigger Lambda, or we can trigger Lambda from the DynamoDB, RDS, DynamoDB, RDS, API gateway. So these services also we should know. Then only we can do the integrate with the Lambda. So API gateway and RDS and the SQS, SMS, right? These are the utility services, right? Like queuing service, notification service, like email service. So how these services will be used in the Lambda? Glue, how can we connect to, like I say, I want to read the data from, so Glue is ETL, we know, right? Okay, and ETL and is a serverless. So S3, I want to read data and write the data to the rest. That is the one use case. I say I want to read the data from S3 and I want to write data to RD. That is another use case. So one source to another source, right? Target. So you can perform with the Glue. So Glue you have to, so that guy was asking like, what are the component of the Glue? Glue component is like we know Glue has Glue crawler. Glue crawler is which is creating a table out of the data in S3, right? Like metadata catalog. So Glue catalog. Okay, Glue catalog is created through, Glue catalog is nothing but Glue table. And this Glue tables are created through crawler. Crawler is like a process. It's process which is creating metadata catalog, okay, from S3 data or any data, not only S3, like metadata catalog from S3, RDS, DynamoDB. See, metadata catalog is like a table, but this table can come from any location. Like my data is in S3, I can create a table. I have a data in RDS, I can create a table out of that. So that metadata table is helpful for the Glue script. So another component is the Glue script. Glue script is your Spark code. This is a Spark Scala or PySpark code, which is using this metadata catalog. Okay. Metadata catalog like job information is there, job information, scheduler information. Okay. And data information, you can say, like what type of data you want to handle, right? So data information. So all metadata information I can say I have in the glue table, metadata catalog. And glue script is a job which is using this metadata catalog and creating, it's running a job. Okay, and another one is glue is having its designer. So designer is another component, that is the drag and drop component. So I will say when you are writing, when you are drag and drop in the designer, automatically the glue script will be created. Okay, so drag and drop area, right? Drag and drop component like source component, transformation component, or target component. Okay. Yes. Okay, so this is for the glue use case, right? Some are the other use case or the like they can ask about EMR use case like EMR. So EMR, there are the different types of node and transient cluster or this long running cluster, and how to configure, right? Like suppose one question was suppose which execution engine I should use, either EMR or glue, if my data is pretty small. Data is pretty small, okay, and I have to process this data. So I think the glue is better choice, right? Because I don't want to use any Hadoop component, so I should not go for the EMR. But if I need my process the data and write data, output data to Hive table, and Hive, I want to do reporting in the Tableau. I want to do reporting in Tableau. Okay, so then I will go for EMR. So depending on the use case, right? This kind of distinction they ask, right? Because EMR and glue both are the Spark, right? Implementation, right? So which one you will follow? Okay, and other cloud, right? If you are interested, right? Okay, there are the other opportunities are there in the market, right? For GCP and Azure, okay, the two cloud. So one cloud is a very strong one. You can keep it. Okay. Anyone has any question? Okay. So anyone has question? You guys getting my voice?
Yes, sir.
Yes, no questions.
Okay, okay. So what I'm saying is like when you are starting the preparation, right? See, this is not a one-day preparation. It is day by day preparation, and preparation will be more stronger when you are attending interviews. Because I'll say, without attending interviews, you can't judge your preparation and you can't justify yourself. There is a one more way, like you are suppose you are not getting interviews, but you can get through the mock can and take anyone, right? You don't need to depend on anyone. You can say anyone, like okay, or otherwise mock preparation you can do yourself also, self-talking, right? You can prepare questions, 20 questions you prepare and give the answers to yourself, and then analyze your answers after like a recording, you do voice recording and then analyze it. So see, if preparation means it's not a single day preparation, it's like a keep on preparation, and the main justification of your preparation is through the mock interviews or real interviews. If you are not getting real interviews, but at least mock interviews you can get through. And before going to someone mock interviews, I will suggest do yourself mock interviews. The first level of interviews are the mock interviews to yourself. Second one, you can go with someone, like someone asking to you question as a like a interviewer, and the third one you can go direct interviews. So I'm telling you, when you will really feel change, right? You feel okay, I'm able to give better to better, right? Like in my self interviews as well as to give someone else or interviewer, direct technical interviewers. So you will really feel the change, and then you will feel the confidence. Okay, because preparation will never be keep ending process, because you cannot say okay, I have done this and I can answer everything, because any one small question comes and that is you didn't prepare it, you have not prepared it, so then you won't be able to answer. So we cannot say 100%. So one cloud you should have a very strong, and other cloud you should go at fundamental knowledge, right? I'm saying you should show in your resume, but keep it in the previous project. Like Azure, you keep it in a one last to last project, you keep it, or GCP, you keep it in the last to last project, you keep it, so that Your resume is reflecting all the different projects, different clouds. Okay, you are showing, and these clouds, because of these clouds, you will be getting a calls. So sometimes Azure calls are there. So I'm saying if you are showing Azure, so at least Azure point of view, you should have some basic understanding about the Azure container concepts is there, blob storage containers, right? And the service group, subscription. These are the admin related. I'm not saying this is a data engineering related. Admin related things are there, like VMs are there, Azure VMs, right? So those are understanding about the admin. Now next come Azure data engineering. So when we comes to the Azure data engineering, we have data factory. Azure data factory, this is like a similar to Glue, AWS Glue, right? Data factory ETL pipeline you design, drag and drop tool, completely drag and drop tool. You can define your and that Databricks is there. Azure Databricks is a Databricks platform. So this Databricks is common, like same Databricks is there in the AWS also or GCP also. So this is the combination of any cloud with the Databricks. Okay? So Databricks is common. So you need to, if you understand Databricks in one cloud, another cloud, you can easily do the setup of the Databricks. So that is not difficult. So Azure Databricks is another one, and Azure Snaps. So Azure Snaps is a analytics service. Analytics service like SQL data warehouse tool, data SQL warehouse tool, like a BigQuery or like kind of in the AWS is a Redshift is there. So these kind of these are services, and Azure Event Hub. Azure Event Hub, right? It's a streaming service. Azure Event Hub, right? A streaming service. Okay. So Azure is mainly these are the data engineering service. If you come to in the GCP, so GCP you should know Dataproc. Last time I did the Dataproc, right? So there is a Hadoop Spark cluster. Okay, so Hadoop Spark cluster where we can create a job and we can run a job. Another one is PubSub is there, like that is Kafka, or we can say SQS is there in the AWS, right? So this is PubSub is another one, and there is a BigQuery, Bigtable, BigQuery, Bigtable. Bigtable is a NoSQL database. It's a NoSQL database as a DynamoDB. Okay, in Azure it's a Cosmos DB. Azure is having the Cosmos DB. Cosmos DB. That is the NoSQL database. Okay, so all the clouds having the similar services, just we need to understand and know which services are there in which cloud. Okay, so Bigtable, NoSQL databases, okay, DynamoDB, and other services in the like Airflow I want to use. So we should have Composer. Okay, so these clouds you can do, but that is necessary. But other than that, some miscellaneous services are there. So those miscellaneous services, like I say, not cloud services, those are the miscellaneous tools we can say. So those tools are mostly those tools are like Cassandra, Mongo, Elasticsearch. Okay, so this is mostly we use integration with the Spark. Okay, Cassandra, Mongo, Elasticsearch, and Kafka. Kafka is coming along with the Spark streaming. So Kafka is there. So Cassandra, Mongo, NiFi, Airflow, and Snowflake. Okay, so these are the all miscellaneous tools, right, which we should know. So it's a full stack developer, right? Like here you are trying for here DevOps I didn't tell, but DevOps also the basic fundamentals of the DevOps services, like GitHub is the first one, Jenkins is the second one, where you should know the CI/CD pipeline of the Jenkins CI/CD pipeline. Okay, and apart from that, the Docker. So Docker, you have seen already the use case, right? Docker Compose I shown, right? How to set up the entire cluster, right? With the Spark, Airflow, NiFi, everything on the Docker Compose, Docker architecture. So Docker is there. And the last is Kubernetes. Like suppose same Docker, I want to replicate as a Kubernetes orchestration tool. Okay. So I can use the Kubernetes. So Kubernetes orchestration with Helm. So Helm chart is directly a package manager. It's a package manager, repository manager, package package manager, repository manager, you can say. So it has all the ready-made repositories are there for Kafka, Airflow. So just we have to import those repositories in our local environment using the ham. So ham chart is a package manager, repository manager, which is having ready-made repositories are there. Okay, Airflow, Spark, Hadoop. So whatever component we think about it, like what we are doing manual setup, everything we can do on the Docker or we can do with the Kubernetes. Okay. So if you divide this entire thing, so 4 sections, right? Complete Hadoop area, then Spark area, cloud area. Okay. And the last is this miscellaneous plus DevOps, right? Or 5 sections you can say. So 4th or 5th section is a DevOps section. Okay. So this is completely full stack and mostly requirement either fall in the some of the tools here. Some of the tools are in the AWS services. Some of the tools in the Spark is completely there. And Hadoop depend on the some of the tools, like maybe they are not saying Hive Scoop, but they are saying HBase, they are saying HDF. So it's like a combination. So we can say the 6 are there in the Hadoop. Spark is there and AWS services and GCP Azure. And GCP Azure, you can just prepare it, just theoretical fundamentals. Okay, if they look for any time, any opportunity for the Azure GCP, so you can present like you work earlier, but not the current. Okay. Okay, anyone has any question? Okay, so start the. So I'll cover tomorrow some GCP services. Actually, I'm preparing the documentation thing, like what are the things, some GCP data engineering. Last time one Hadoop, this Spark cluster, but some BigQuery, Bigtable, PubSub, Composer, these things I can show. So these are just hardly like 1 or 2 day things practice. Okay, like if you have the scenarios like because if you have ready-made code like this Spark code you have, like you develop some Spark, so I can use any cloud to deploy. I can use any cloud for the infrastructure. So this cloud is giving infrastructure, like it is giving a EC2 instance or VM, or it is giving you Dataproc, or it is giving a GCP is giving you Dataproc, Azure is giving you SD inside, AWS is giving you EMR. So these are the infrastructure services, right? So infrastructure, or as well as we can use write same Spark code, we can copy paste there, right? Okay, so it will work in the cloud. So whatever I can run in my local on premises, I was doing testing of this job. So same I can do it here. It's nothing different. So you need to learn, one is the application side, another one is the infrastructure side. Infrastructure side, mostly you have to learn in the cloud, right? How to prepare your infrastructure, right? How to prepare an EMR cluster, GCP Dataproc cluster. But this is just a click of things, right? Just do some clicks and then you will get the cluster ready. Okay, you don't need to do any much effort on that. Okay, so if you have prepared on the on-premises like development, right? Like how to prepare a job, how to create a jar, or how to application side is learning important, like how Spark code we can write. Okay. Okay, I'll share the video and this text document. Okay. And anybody is interested to learn on this project, I'll share the code. Okay. So don't share to others. Okay. So just keep it to yourself and learn. Check the logic. Okay. Because I have written step by step. So if you plan to write, so first you got the idea. Okay. Like how all these things are happening. Okay. When you look at the code, you can easily understand where I have put this logic, where I put this logic. So how you can also develop the same thing from the scratch. And like small things you can find from the ChatGPT. I'm telling you, I'm getting really much help from the ChatGPT, right? For anything, if I want to search, I quickly find like, okay. So nothing is difficult, right? Like if you are going to search something, like I had a one scenario I wanted. I have a tool list. Okay, these are the integer number, but I have a string data. Okay, I wanted if one list have some value, but second list doesn't have this value. So it's kind of difference, right? List one to list two difference. So in the Scala, it's very, very easy, right? Just like a diff. Okay, you will get a difference. Okay, you will get something is in this list, but not in this. Like it's like a, union functions are there, right? Subtract function or like the, like those kind of functions we use, right? Okay, even union we also use in the Spark one. Okay, but here is a simple basic list one. So Scala has already this kind of utility. So I got this one place, right? I have a one input list and one is a output list. So I want to filter out which is present in the input and not present in output. So I can make it one list I can put. Okay, so this kind of scenario I get it here. Okay, so I'm telling you, whenever you thinking the logic, you can get it. Okay, like how to read a file, how to infer schema, how to apply header to. Okay, this kind of thing. Some more logic, right? This 10 minute file you want to write, right? Head.sleep you put it. So you write the data first time, write the file. So you got the list of all the dates you have and you want to write the data. So first you write data and then thread.sleep you put 600,000 milliseconds. So it will be 10-minute delay. So that will make it your, okay. Suppose I want to based on the like whether there's a current file, it's a current date, or it's a like if okay, one problem was coming, right? Okay, my file is the text file where I'm writing a date, right, which I'm reading date. So I want to write a common function if I'm reading either date or if file is empty, both it will read. So if file is empty, so it should return empty. Otherwise, if I'm not writing this condition, so what happening, this one is returning a date and this is returning a string. So both are different type, right? Both are string, but format is different, right? Here is a date type of format and it is like a string format, right? So I need to make it a distinction, right? When I say my empty, so I have to put a one empty check. When I don't have any date in my file, when I read my file and I don't find any file, if my file is empty, so I should return a blank string. Or if I'm not returning this blank string code, I just write this one. So what error I was getting? I was getting error, parsing error. Because whenever the file is having empty data, so this thing will give error. Okay, so you don't need to run this logic when the file is empty. So you differentiate the file, whether it's an empty file or you have date in the file. Okay, so this kind of logic I took it. Okay, one convert logic is there. Actually, I have a file is a hyphen in my text file, and I want the simple just the hyphen I have to remove. I have to make it without hyphen. Or I have to take it a date pattern, right? Suppose in the file, if the file is this, okay, and I want to get only this date 2023-0802 till here I have to take. I can write the logic very easily by using substring function. We know substring, right? I take it first, dot is my last index of, and I have an underscore last index of, so I can get this value. In this value, I can take first 10 character. So 2023, 8 character. I will take it first 8 character. That is a one way. But if I'm doing the regular expression, so I'm just taking a D8, right? So all 8 digit it is taking, right? Before underscore and dot. Okay, this underscore and dot in between the dot. So I'm taking a D8. So in this D8 character, I divided 0 to 4 is year, 4 to 6 is my month, and 6 to 8 is my day. And then I'm returning this form. Okay, just check like this function. So many things you can quickly get it, right? You can get quickly. Okay, and one more thing is, right, that you remember, right, Is a very complex number. Okay, so I created a pair, right? I create a pair of the files. Suppose I have a two files. So how many files will come? Two only, right? If two files in the folder, so in the pair will come two files, right? Two files will come, right? But in these two files, one file is a failure file. One file is a failure file. Okay, so how many files will go to the success one? Only one file will go to success. Okay. So this pair which I got at two files, I have to reduce also. Because in the success one, I'm iterating again. I want only one file one, but my pair is still two. So I have created a one. Initially, I created a two pair. One is a pair and one is I created pair one. Both are the same size. Pair, and pair one. Okay. And both I kept it two. I kept it two size because initial size is two, right? Before the validation. So what I did, this two pair, I always iterating this pair here for the all failure message, okay, pair. But when I come to success, so I created a pair one. So this pair one is I'm reducing here. I'm reducing here. Pair is keep running for the original like two files, but pair one I prepared this pair one I updated with the one file. I reduced the one file. So here pair one size is two, but here I pair one I made it reduced to one pair, right? One file pair. Okay, reduced to one. And this pair one I'm using here for final success one. Okay, why I'm doing like this? If I don't do this, so success will again iterate for two only, but I don't want the two, right? So I have found this logic here. So here, suppose I have initial list is there, okay, and I want to remove a particular B and C key. Like I say B and C, these two entry I want to remove. I want to keep it one or suppose this is example of your four files pairing, okay, A file, B file, C file, D file, and you came to know B and C file, but this is in the dynamic in my case, okay. So what I'm doing is this particular line I'm adding in my each validation. So wherever whatever key I know this key is which file it is. So when I come to know _1 means the first entry, if it is equal to my file name, right? Either A or B or C or D. So it will filter out, filter not, what it will do, it will remove this key and it will give this many filter. Second time is, okay, first time is B is removed here. Second time in the second place, C is removed. Finally, I will got this one. And this one is my final pair for my success. Okay. Got it, this one? Understood this logic? This is general logic I am talking about, but I'm saying, yeah, but I'm saying that this kind of logic is needed, right? When you want to reduce your entries, because you want to do the final run on your success file, which is not the error message one, right? Okay. So this kind of one single line I use in my code, this line, okay, because these all are already there in my, okay, pairing is there, but only thing is I need this single line. So this single line I put in each validation message. So how many files comes fail? Suppose in count validation, all files fail, or I said 3 files fail, only one file is there, and 3 files count validation failed. Okay, so what it will do, these 3 files it will remove, only it will keep it one. Yeah, and that one I have to process. Okay. Yeah, so prepare like this, okay, and see, this is now you will get the scenario, then you can think about it. See, I'm also getting the first time this kind of scenarios and implementing, but I'm saying this will develop your logic mindset, right? Okay, like where you are getting the errors, issues, right, and then you have to correct it. Okay, because you have to keep on validating your data input, and then you will be correcting, and then you will be reforming the logic, right? Designing the logic, right? Okay. So this is keep on changing process, right? This is not in the one go you will apply logic and it will verify. It will work. Sometimes you have to keep apply, and then you have to change logic, right? You have to think in a different way, and then find a correct logic and then apply. Okay. Yeah. So try like this way, and do practice on that. I'll say that. See, this is not interview point of view. I will say this all net, but this kind of things, if you prepare in your mind, and you can prepare the scenarios, so even in interviews also this kind of challenges you can tell, but you have to think about something. It's a bigger challenge, right? It's not like a small logic code you are going to tell, but at least some bigger challenges, right, where the performance issues or those things you can take it example in the interviews. Okay. Yeah. Okay. Yeah, thanks everyone. I'll share the recording in the classroom one. Okay. And code also I will keep it. So I will share to you for guys, because nobody took interest. So I don't want to share with everyone. So I feel like who is really interested and want to learn and work. Okay. So if you think something more different idea or some different way, or like you think, okay, wherever you are getting stuck on that code, right? So I can give you the running code. Even you will run in that one attempt, you will run it, and you will understand. But I say better way is like take the copy and then prepare, start doing development things, like start small things, use cases, and divide the code into pieces and steps you define, and then start working on that. Okay. Got it. Okay. Yeah. Thanks everyone. Thank you.
Yeah.